talk about factorizing polynomials. So basically factorizing is, well, the opposite of, well, working stuff out. Basically you're trying to write something as in a certain way that could reveal answers to you. And we already did that kind of with Horner and long division. That's the reason all of this, well, this is one class. So basically we're always trying to simplify things or work things out and try to see if we can, well, glean some information from that. So for this, let's go to exercise 2.1. I just called it like that for convenience. Let's go there and let's have a look at that. So B. And exercise B is minus 4x to the power of 7 minus 3x squared and all of that to the power of 2. Okay, so this is pretty simple. It just follows the logic of A plus B squared is just A squared plus 2AB plus B squared, right? So we can pretty easily follow this. So if this is A, let's square it. So what do we get? Minus 4 squared gives you 16. X to the power of 7 squared gives you x to the power of 14. Okay, then 2ab. So, well, we need to check these minus signs. Okay, negative, negative, to cancel each other out, no problem. So we get 2 times, okay, I'll just write it in full, minus 4x to the power of 7 times minus 3x squared. And then b squared, so we're going to say plus 9x to the power of 4. So all that's left for us is to rewrite this part over here. So what do we get? We get 16x to the power of 14 plus 2 times, so that's 8. So that's 24x to the power of 9, because 7 plus 2. And then plus 9x to the power of 4. And that's pretty much as far as we can get, because we just have to work it out. So basically we have to get rid of all the things, we have to get rid of the brackets and all that kind of stuff and see how far we can get. Okay, that's for question B. Let's have a look at question D then. And here it is, much the same as before, but now it's raised to the power of 3. 2x to the power of 3. And this takes a little bit of a different approach, a different, conclusion, one might say. Because, well, now it's not to the power of 2, and, well, you will see if you say, basically, where did these things come from? You say, well, a plus b to the power of 3. Well, what's that going to look like? Well, you can rewrite it as a plus b times a plus b times a plus b. So you're actually going to have even more factors, right? Okay, so what's the general formula for this? You don't have to learn this by heart, but it's definitely good to know. So you get a to the power of 3 minus 3 a squared b plus 3, and then I have to be careful here, because this is actually in case of minus, so we have to do minus, and so then here these all are all minus. So minus 3a b squared minus b to the power of 3. Of course, you don't have to know this by heart, but, well, you can obviously find this, and then, well, you can also rewrite it as a minus b squared, and then just times a minus b if you don't remember it. So this is a little bit of a shorter way if you don't, instead of doing the whole long things, because you already, most of you are already familiar with how to work out this. Okay, so first things now we need to find is a to the power of 3. So a is 3x to the power of 3. We're going to raise all of that to the power of 3. So we're going to get 27x to the power of 9. Okay, then minus 3 times a squared. So that gives you 9x to the power of 6. Times b, and in this case b is 2x, so we're going to say times 2x. Okay, I understand it's a bit confusing here because, well, why am I not including this negative sign here? Because, well, I defined it as if, well, here there was already a negative sign in between. You could, of course, write it as just a plus b and then just consider the negative sign in there and then just keep track of only one formula. But, well, I wrote this one down, so we're just gonna go on with that one. So plus and then 3 times a, so you get 9 x to the power of 3 times b squared, so that's 4x squared, and then minus b to the power of 3, so that's minus 8x to the power of 3. And all that's left to do is now we'll bring this all together, so you get 27x to the power of 9 minus 27x to the power of, no, it's not 27, it's 54. I forgot the times 2x, so it's times 54x to the power of 7 plus 36x to the power of 5, and all of that minus 8x to the power of 3. Okay, so that's the way to solve these kind of things. And in general, well, you can of course figure it out and just write it the long way around, but most of the time it's useful to know at least a couple of shorthands, like, well, to solve your mathematical exercises. Okay, then maybe one more for this, and let's look at f. And f is interesting because, well, actually it's kind of like a trick, because, well, you remember this trick, a minus b times a plus b is equal to a squared minus b squared. Well, so this would be the complement to that. Well, there is also a third degree complement. Such a thing exists. Okay, and let's have a look at that. So in this case, the exercise is minus 2a plus 3b times 4a squared plus 6ab plus 9b squared. Okay, and why is this the shorthand? Well, you can look up the rule a little bit later, but basically these things here in the middle that we talked about before, well, if you do this, they're gonna cancel out. The same reason as why it works for a square, it also works for a cube root, a cube power. So in this case, well, let's check if it works. So a, this would be a, this would be b, and then, well, you can find earlier on the exercise sheets what the actual formula looks like, and we would need to find a squared. Here we would have to find minus ab, because it's a plus b here, and then plus b squared. And let's check if that's right. So, okay, let me get a different color for that. So a is minus 2a, that's squared. Okay, checks out. Minus ab, okay, let's have a look. So minus 2a times 3b would give you minus 6ab with a negative sign in front. Okay, it is indeed minus ab, so checks out. Okay, then b squared, okay, 3b to the power of 2 gives you indeed 9b squared. So it is true that this times this is just going to give you a to the power of 3 plus b to the power of 3. So we can quickly rewrite it, knowing that this is a. Okay, well, we can quickly find it. So it would give you minus a to the power of 3, because we raise this to the power of 3, and then 3b to the power of 3 is going to give you plus 27b to the power of 3. Okay, and so this is how we can work these general exercises out. A couple of really recommended exercises you can do at home would be, well, the two that we didn't do. Oh, so sorry, I missed. I took the wrong number here. It is E, and that are recommended for home, and that's just recommended for home are A and C. So basically all of them that we didn't do together. Okay, then let's go and have a look at factorizing. And factorizing, well, basically the goal is, instead of like working out, is to write it in a certain form and, well, simplify it as far as possible. And here we're going to make a couple of them together. For example, we're going to start with A. 4x squared plus x minus 18. And here we're going to use a discriminant. And the discriminant is going to give you a couple of results. Because, well, we haven't really talked about functions yet, but it's actually a second degree polynomial. And a second degree polynomial will always look like something like this. It's going to allow you to have two different roots. A root over here and a root over here. Or, in another case, it could give you a root where it would look something like this. So x squared would look like this. And in this case, you still have two roots. It's just they're overlapping. So 0 is going to be the same root twice. So this is why the discriminant is always going to give you two possible results. So by factorizing, I mean, well, we write it as something like, well, try to write it as much as a multiplication as possible. Okay, let's try that. And for this, well, because this is a second degree polynomial, you might think, okay, we can immediately do Horner, but for second degree polynomials, it's much easier to do the discriminant. And the discriminant, you probably might all remember, it works like this. B squared minus 4ac. Okay, so what are these things? Well, b is basically the number that's in front of x. So in this case, it would be 1. So 1 squared. And then minus 4ac, okay, then we need to figure out what a and c are. So a is the number you have in front of x squared, and c is the number you have. That's your constant. Okay, so we can write this out. So it's minus 4 times, okay, let's look for a is 4, times c, which is, in this case, minus 18. Okay, so that's going to be the value of your discriminant. Okay, and if you work that out, and this is probably a more complicated number than we would ask you on the exam, but it is 1 plus 288, so it's equal to 289. Okay, so how can we convert this back to these roots? Well, actually you say, well, they follow a certain pattern, and the way you can write them, and the professor is going to explain where this comes from in class, but the general pattern we find is that it's going to look like this, where they are, over 2a. So minus b plus minus the square root of your determinant. Okay, so let's fill this in and see what we get. So we get the determinant, which is 289. I'll tell you just now that that is equal to 17. Plus minus, okay, let's look for b again. Okay, so that was 1. So minus 1 over 2 times a was 4, so you get over 8. So that's going to give you two possible solutions. One where you add the square root and one where you subtract the square root. Okay, so the first one we're going to find is going to be 2. In this case, you're just, well, adding it up, so you get minus 1 plus 17 is 16, divided by 8 is just 2. And in the other case, you find that it's minus 18 over 8. Okay, so still you tell me, well, this is not really a solution. Well, remember that earlier in the lesson I said, well, if things look like this, well, it's very easy to read off where, well, things become equal to 0, where your roots are going to be. And basically the root is going to be where these kind of things contradict. So when x is equal to a, this is going to become 0, and then your entire multiplication is going to be 0. So now when I tell you these are the roots, well, we can rewrite them as roots as well, these things, because, well, we just discovered that these are the roots. So what do we say is x minus 2, because if the value of x is 2, you're going to find a root. And the other one is going to be x. And let's simplify this a little bit, because we can still divide it by 2. We can say minus 9 over 4, x plus 9 over 4. Okay, that looks very nice, but maybe we don't like to work with this fraction over here, and so we can say, okay, it's x minus 2. And then, well, basically what we're going to do is we're going to do times 4 over 4 for this second part, which we can just do because it's times 1, so we get 4x plus 9. Okay, depends what you think is more convenient. This is also just fine, but this is how you can factorize it, and basically everything becomes a multiplication. So either you answer this or you answer this. Both are good. Okay, that for the discriminant, how it works, and what the finer details are of how to discover these things. Please go and look at the lectures. It's a bit long to discuss now in the exercise sessions. Okay, then let's go on and look at exercise C, which is 2x to the power of 3 plus x squared minus 5x plus 2. Okay, so we want to factorize it, so write it as a multiplication as much as we can, but, well, it's not as simple as what we did before, because we don't really find anything, well, possible that we can do with the discriminant. And some of you might already have heard about it. There is such a thing like a discriminant for a third power polynomial. I encourage you to look it up, but it's very, very complicated and very, very long to remember. So in this case, what's best to do is, well, let's see if Horner can help us out. Okay, so let's rewrite it. What do we find? We find, well, 2, 1, minus 5, and 2. So these are basically the numbers where we're going to work with Horner. Okay, let's have a look at this 2 over here. What are the possible dividers for 2? It's going to be 2, minus 2, 1, and minus 1. Okay, so these are our possible candidates. And let's start with the smallest one first. Let's start with 1. Okay, let's see if that works. We drop 2. 1 times 2 is going to give you 2 over here, so you get 3. Okay, great. 3 times 1 is just again 3. You get minus 2. And then minus 2 times 1 is just minus 2 again, 0. Okay, so what we found already is that, well, we can rewrite it a little bit. We can rewrite it as x minus 1. Remember, the sign switches over here, times 2x squared plus 3x minus 2. And now you can either go further in Horner, so simplify it even further. I'm going to show you both methods, or we can go for the discriminant. But let's first simplify it further with Horner. So let's draw this underneath and see if we can do something more. So the dividers for minus 2 are just the same as before. Well, we already singled out 1, so maybe there's another 1 in there. Let's see. Sorry, this needs to be 2. So it gives you 2. Okay, this is clearly not going to work because we're going to end up with 5, and 5 and minus 2, that's not going to work. Okay, so we can try minus 1. Okay, let's drop it again. We find minus 2. We find 2. Okay, so, sorry, not minus 2. We find 2. And here we find minus 2. So we get 1. Okay, so also clearly not going to work. Okay, let's try something different then. Let's try another one. There was still minus 2 that we can try. So we drop it. We get 2. Here we get minus 4. Okay, great. We find minus 1. Minus 1 times 2. Okay, 2, 0. Okay, simplified. And then we can say, okay, great, this has been simplified, well, factorized as far as we can. We can just say x minus 1 times x plus 2 plus, well, all that's left over here, which is 2x minus 1. So that's one way to factorize it. The other way would be to use a discriminant on this part. Okay, and let's do that together once too. And you'll see I don't keep writing where A, B, and C are, but I'll just do it now. So these A, B, and C. Careful not to forget the possible minus signs that are in front of it, and let's see if we find the same answers. Okay, so we get b squared minus 4ac is equal to our discriminant. Okay, let's fill that in. So you get 9, okay, minus 4ac, so minus 4 times 2 times minus 2, which is, well, these negative signs are going to cancel out, so this gives you, well, 4, 16, so 25. Your discriminant is 25. Okay, that's neat because the root of 25 is 5. That's all I did here. So minus b is, if you go and look, it's minus 3, and all of that over 2 times a, which is 4. Okay, so either it gives you minus 2, if you do the minus 5, and if you do plus 5, you're going to find that it's 2/4. Okay, and then just I'm going to ask you to do that for yourself, but verify why this 2/4 is the same thing as what we wrote over here. Okay, that's pretty much for question C. Let's have a look at question E then, which is a bit more challenging. And I'm also not going to make it completely, but I'm going to strongly encourage you to follow along and then try and finish it by yourself. So x to the power of 27 minus 1. Okay. Okay, this looks very messy, and somebody might already say, well, we can take out when x is 1, this is going to become 0, so maybe we can factorize that way. And yeah, you're right, we can definitely do that, but in this case, it's not going to be the best way to really simplify it, because then you're going to get up with something with that's going to run up all the way to x to the power of 26, and well, then you're just calculating really a lot. So let's see if there is not a simpler, more elegant way. Okay, what we could say is, well, 27 is divisible by 3, right? It's 9. And this could also be a third power. So what if this is a to the power of 3 and this is minus b to the power of 3, right? So in that case, we could rewrite it as a plus b times a squared plus ab plus b squared. It's one of those tricks you can use and to find a to the power of 3 minus b to the power of 3. And I think I'm forgetting here a minus sign somewhere. Let me have a look. So yeah, I am forgetting a minus sign over here somewhere, and it is over here. This should be a negative sign, like this. Okay, so you get a minus b over here. So okay, let's fill that in. So if this is a to the power of 3, well, what's a then? Well, a would be x to the power of 9. That's a, because, well, x to the power of 9 to the power of 3 would give you x to the power of 27. Okay, and b is just, well, it's just 1, so you're going to find minus 1. Okay, and then let's have a look at a squared. Remember, a is x to the power of 9, so it would give you x to the power of 18. Write it a little bit clearer, plus ab, which is x to the power of 9, plus b to the power of 2, which was just 1, so it would just give you plus 1. Okay, that already kind of simplifies things. We don't have x to the power of 27 anymore. And, well, I'll let you verify why this doesn't work, why you can't, well, simplify this anymore, or why things get really messy here. But basically the goal of this is basically for you to get familiarized with this a to the power of 3, and so, well, you could maybe work it out a little bit more. It's not really necessary. So you can just leave that over here. But we can still do something, well, with this, with the other part, with x to the power of 9, because again, 9 is divisible by 3, this thing here. So we could again say, well, let's use a different color and say that now this is a to the power of 3 and this is b to the power of 3. So let's rewrite it a little bit again. So if this is a to the power of 3, that means that this becomes x to the power of 3, right? Because x to the power of 3 to the power of 3 would give you x to the power of 9. Okay. And then here it just stays negative 1. Okay, and then, well, we still need to find this entire thing. So now this is a and this is b. Okay, let's work it out. So what do we get? We get x to the power of 6 plus x to the power of 3 plus 1. And all of this, because this is just a simplification of this thing over here, times x to the power of 18 plus x to the power of 9 plus 1. Okay, we can still simplify it a little bit further. We can basically simplify this over here, and then this is going to be, well, your homework. So do this at home. Okay, then maybe one more before we end up the video. Let's go and have a look at question H. And here, well, basically this looks very long, and it is, but what I want you to do is look at all of the individual parts and see how you can factorize them. So minus 1 x squared times x minus 1 x to the power of 3 minus 1 minus x minus 1 to the power of 3 times x to the power of 4 minus 1. Okay, this is a whole thing. Let's try this. So first things first, you could say, well, this thing, it kind of follows the logic of a squared minus b squared, right? Which would be equal to a plus b times a minus b. So we can rewrite it, and we can already expand that a little bit. And so what do we find? We find that it's x plus 1 times x minus 1. Okay, this thing, we can't really simplify it anymore because it's already written as a multiplication. It's just x minus 1 times x minus 1. So we can just rewrite it as, we can just leave it as it is. And then we get x to the power 3 minus 1. Okay, maybe we can get to that later, because here definitely we can do some simplifying. And then over here, well, we can't simplify as that much either, but here again, some simplification is possible. And here again, and I'm not going to give it to you, but my hint would be a squared minus b squared, that you can simplify it like that. Okay, so let's have a look at this thing over here. And maybe we can use Horner to solve it, because, well, we have 1 times x to the power of 3, 0 times x to the power of 2, 0 times x squared, and minus 1. So basically, what do we have? We have x to the power of 3 plus 0x squared plus 0x minus 1. Okay, great. This looks kind of promising, because, well, maybe we can definitely simplify it, because, well, minus 1 is only divisible by minus 1 and 1. So we only have 2 to try. Okay, so let's try 1. And I think 1 is our best candidate in this case, right? So let's try this. 1 becomes 1, this 1, and in here it's still 1 and 1, and here 1 again, and so you end up with 0. So yes, we can definitely simplify this. So we can just write it as already x minus 1 times x squared plus x plus 1. And then minus, well, this thing behind it. Okay, so for this, I'm going to remove everything we just did. If that went too fast, you can just pause the video, of course. Okay, and this, well, this looks like a good candidate to simplify with the discriminant, x minus 1 to the power of 3. And then this, I hope by now you have found it, but this would be x squared plus 1 and x squared minus 1. Okay, so maybe we can simplify it still a little bit further. So this x squared over here, we can still simplify it, and we can just do that using the discriminant. Or let's see if we can simplify it using the discriminant, because maybe it's not possible. So we get, okay, this b. Okay, so 1 squared minus 4ac, which is going to give you minus 4 times 1 times 1. So we end up with a discriminant that's equal to -3. Okay. And in high school, you might have remembered, okay, discriminant is negative. Basically, you can't simplify it any further. Basically, there is, well, it doesn't give you any solutions. And that's true, that's definitely true. And it's true when you work with only real numbers. As soon as you start working with complex numbers, this becomes possible. In here, in this space, it's definitely okay. And that's also what's meant in the theory bundle, where they say it depends on the space. Of course, complex numbers are for later, so all I ask you for now is, well, you found that it's -3, so it means you can't simplify this any further. So this is the simplest that's possible. Okay, then let's see over here, x squared plus 1, something to the power of 2. Well, it can never become a negative number. Well, it can if it's in the complex field, but we're in the real plane, so it doesn't really matter. So in this case, we can't simplify it any further, and then we can still maybe simplify this over here. And actually, yes, we can. So we can rewrite it completely again, and let's basically contract all of these things. So x minus 1 to the power of 4 times x squared plus x plus 1 minus x minus 1 to the power of 3, x squared plus 1, and this becomes x plus 1, x minus 1. Okay, so I think we cannot simplify it any further than that. All we can do is, well, cross this one out and raise the power over here, and then we'll have, this is as simplified as we can, and now we can write this, well, we still have this subtraction over here, so let's try and get rid of it as far as we can. So they share in common this part and this part. as you see, they both have the same things over there, so we can rewrite it as x plus 1 times x minus 1 to the power of 4 times, let's write bigger brackets, x squared plus x plus 1 minus the things we didn't cancel out, which is x squared plus 1. And then, of course, you're allowed to simplify this even further, and now you can just work it out as an addition over here. And then you will see it will become even simpler what's written here. I'll let you do that, and I'll give you the answer in a couple of seconds. Oh, I see I made a mistake. I'm sorry. This should be minus 1 over here, because, well, there is a negative sign in front, so minus x squared minus 1. So these cancel it out, so all that's left is x. So you find a neat multiplication, and here it's very easy to find all of your possible roots. Okay, I hope this was clarifying. This is the end of the second video. There's only one more video, and there we're going to start with equations, and we will use all the tips and tricks we just used to basically, well, start doing and working toward more economic problems.